This video is for Unit 8.3, going over strong acid and strong base titrations. So remember from our previous lesson, a strong, either acid or base is going to dissociate completely, which is why we see that the net equation for a strong acid, strong base titration is that we have our hydronium, which is our acid ion, plus our hydroxide, which is our base ion, combined in equal molar, we're going to have only H2O being produced. So the equivalence point, the moles of the H plus and moles of OH are equal. And so when they go to combine, they just cancel each other out and become water. So when we are looking at ice tables or when we're dealing with the concentrations of acids and bases in a titration, we must plug in moles. What's nice about a strong titration is that at equivalence point, we know that the pH is 7 because if the moles are equal, then the only thing that we have is water, so the pH is going to be 7. So the salt that's present, our NaCl, that is just our spectator ions, so we don't include that in the net equation. So we are going to use the following equation to find molarity of volume of the unknown, and that is, we've said like M1V1 equals M2V2. It's slightly different in that we have MaVa, which stands for acid, and then MbVb, which stands for base. So here are the steps for graphing titration. So step 1, we're going to find the initial pH of the analyte. So whatever we're starting with, we're going to find the pH of it. So if it's an acid, we can find the pH by taking the negative log of the hydronium. If we're given a base, we can find the pOH by finding the negative log of the hydroxide and then using 14 minus whatever the pOH is in order to find the pH. For step 2, we're going to find the volume of the titrant added to reach equilibrium. That's where we're going to be using the MaVa equals MbVb, and remembering that pH is at 7. For step 3 and step 4, these are the ones that are a bit more involved. For step 3, we're going to find the pH of the halfway to the equivalence point. So it's going to be half the volume that we found in step 2. And what we'll do is we'll find the moles of whatever starting solution we have. Usually it's an acid, but sometimes it's a base too. So whatever our analyte is. And then we half that as well. Once we find those moles, we're going to find the new molarity by dividing by the total volume. So whatever the starting volume of your analyte was, plus whatever the halfway volume was from step 2. And then once we have molarity, then we're going to plug it into our negative log and then potentially using 14 minus pOH in order to find pH. For step 4, finding the pH of past the point of equivalence, you just want to choose a volume that is a volume above your equivalence point in order to have that final point in order to complete your graph. So let's go into an actual practice problem of this. So we have 20 milliliters of 0.030 molar HNO3. So this is an acid. And it is titrated with 0.40 or 0.040 molar KOH. And we're going to graph this titration. So since we do have an acid, we can, and these are strong acid, strong base, we can, for part A, find the starting pH, and this is at a volume of 0 milliliters of our base added, because when we go to graph, this would be at 0 on the x-axis. So our starting pH, I'm going to take the negative log of the concentration. Since it's a strong acid, I know it's going to dissociate completely. And I am going to get a pH of 1.52. So I have 2 sig figs, so I'm going to have 2 decimal places for my pH. So that's my first point that I will make on my graph. For step number 2, at equivalence, I know that the moles are equal. So again, I'm going to use that MaVa is equal to MbVb. So my molarity of my acid was 0.030. The starting volume is 0.020 liters, is equal to my molarity of my base is 0.040, and then I'm solving for my volume of my base. I know that at equivalence, my pH is going to be equal to 7. So when I solve for VB, I get that VB is equal to 0.015 liters, which is equivalent to 15 milliliters. Okay, so I have my starting point, I have my equivalence point, so that's 2 of the 4 points I'm going to make on my titration curve. The next thing is my halfway. So I need to figure out how many moles I started with my analyte, which is my acid in this case. So for my HNO3, I had this is where we're going to use molarity is equal to moles over liters. So my molarity was 0.030 is equal to moles over, and then volume 0.020 liters. So when I multiply, I find that my starting moles is 0.0006 moles. And then I like to put what ion I'm dealing with here, which is H+. So since I'm at the halfway point, I'm going to take half of those moles because that's what's going to remain since half of them are going to be consumed with the OH molecule or ion. So I'm going to have 0.0003 moles of H+, and then I'm going to divide that by the total volume in order to figure out the new molarity in order to take the negative log of that. So at halfway, I'm going to have a volume of half of whatever my step 2 was. So I had 15 milliliters there. So this is going to be 7.5 milliliters. So my acid, I had 20 milliliters. I added 7.5 milliliters. So that's going to be how I'm going to find my new total volume. So I had 0.020 plus, and then be careful with the 7.5. It's 0.0075 for my new volume. So when I divide that, I got a new molarity of 0.01091 molarity. And again, I like to label this is H+, so that I know that if I take the negative log of that, I'm just going to put an arrow. That's going to give me my pH. And I got a pH of 1.96. Okay, so now I have 3 points. I just need one more, which is my kind of ending point after equivalence. And at this point, I can pick any volume. Since my equivalence was 15 milliliters, I'm going to choose 20. So at 20 milliliters, I'm going to figure out what the new molarity or what the new pH is going to be. So for this, I have to figure out how many moles of KOH am I adding. So for KOH, it has a molarity of 0.040. Okay, the volume I'm adding is 20 liters, or 20 milliliters, so 0.02 liters. So that is equal to 0.0008 moles. And then again, I like to label, this is my base, so my hydroxide. Okay, so now I'm going to have an ice table. Okay, and when I'm doing titration, I have to use moles to plug in. So my initial moles, I found my initial moles for my hydrogen in step number 3. So I had 0.0006. Okay, and then for my OH, I had 0.0008 that I'm adding if I'm adding 20 milliliters. So I know I'm going to shift forward. And since they're 1-to-1, the smallest amount is going to be consumed. So my hydrogen is going to be consumed. Okay, my water is just a liquid, so that's not relevant. So I'm going to have 0 moles of my H plus, and I'm going to have 0.0002 moles. And again, I like to label of hydroxide. Okay. So now that I have moles, I want molarity. So I'm going to divide by the total volume. So I had 20 milliliters from my initial acid. I added 20 milliliters of my base past my equivalence. So I'm going to have my 0.02 plus 0.020. And I'm going to get a new molarity of 0.005. And this is my molarity of my hydroxide. So I do like to label it. So now that I have the concentration of one of the ions, specifically the base ion, I could do the negative log. That's going to tell me my pOH. So negative log of 0.005 is going to tell me my pOH of 2.30. And if I subtract that from 14, my pH is going to be 11.70. So now I have my 4 points that I can then go and graph. So I have 1, 2, 3, 4, 5, 6. This is 7. And I think I'm going to count by twos. 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. Okay. So for my first point at 0 milliliters added, because this is my base added, I'm kind of running out of room. In milliliters. 0 milliliters, I had 1.5, so about right here. At 7.5, so 2, 4, 6, 7.5, I had a pH of 1.96, so about here. And then my equivalence point was at 15 milliliters, so 10, 12, 14, 15, and then that's going to be at 7. And then my after equivalence point at 20 milliliters, I had a pH of 11.7. So 7, 8, 9, 10, 11, almost to 18. Okay, so for this, I'm going to come in flat. I'm going to have my steep curve, and then it'll flatten back out as it becomes only base. Okay, the next problem that I'm going to be doing, I'm looking at a base being titrated with an acid. So similar steps, but we just have to pay attention that we have the hydroxide ion instead of the hydrogen ion that we're starting with. So for starting pH, just like we did before, we're going to take the negative log. This is a base. NaOH is our analyte. It's a base, and we're titrating with HCl, which is contributing the hydrogen, which is the acid. So our NaOH, we're going to take the negative log. So this will be our pOH. Will be the negative log of 0.1. So my pOH is equal to 1.00 because I'm going to have 2 sig figs, which means my pH is equal to 13.00. So that's our first starting point. For equivalence, again, I'm going to use the MA, VA equals MB, VB. So my molarity of my acid, which is the thing I'm titrating in, is 20 molarity. I'm trying to solve for my volume of acid I add. My molarity of my base is 0.10, and then my volume is 0.025. So when I solve for my volume, I have 0.0125 liters, which is equal to 12.5 milliliters. Remember, at equivalence, we have a pH of 7. This was a volume of 0 milliliters of our acid added at that point. For our halfway, I have to figure out how many moles of my base I started with. So I have my NaOH, and I'm going to take its molarity. So 0.10 is equal to moles over volume, 0.025. And I'm going to get that I have 0.0025 moles of hydroxide, OH. Remember to include what ion so that you don't get confused. And then we're going to divide that by the total volume because I added together. At halfway, it would be half of 12.5. So I've added 6.25 milliliters of acid. So my starting volume of my base was 0.025 plus the added 0.00625 liters of acid. I'm going to get a concentration of 0.04 molarity of hydroxide. So since this is hydroxide, I'm going to find the pOH by doing the negative log of 0.04. And I'm going to get a pOH of 1.40, which means my pH is 12.60. And then lastly, for equivalence, since I had equivalence at 12.5, I'm going to go ahead and just do 20 again, just because it's far enough away from the equivalence point. So I need to figure out how many moles of acid I'm adding if I add 20 milliliters. So my HCl, I have 0.20 molarity is equal to moles over 0.020 liters. So I'm going to have 0.004 moles of H plus. So now for my ice table, for acid, I just found I'm going to add 0.004. For my OH, if I look back at step number 3, I had 0.0025 moles of my hydroxide. That was right here that I found. Okay, so I know it's going to move forward, so we're going to subtract the smaller amount, so the 0.0025. The water is a liquid, so it's irrelevant. So I'm going to be left with 0 moles of hydroxide and 0.0015 moles of H plus. Well, since I have the moles, I need to find the molarity, so I'm going to divide it by the total volume. So for my base, my original base, I had 25 milliliters, so 0.025 liters plus, and I added 20 milliliters of acid, so 0.020 liters of acid. And I'm going to get a concentration of 0.033 molarity, and this is of H plus. So if I do the negative log of 0.033, that's going to give me a pH of 1.48. So now I have all 4 points. So 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8, 10, and 20. Okay, so my starting point is at 0 milliliters of acid. So this is my pH. This is my acid added in milliliters this time instead of a base. I have 0 milliliters is at 13. So 7, 8, 9, 10, 11, 12, 13. So that's my starting pH. My equivalence at 6.25 is at 7. Or at 12.5, sorry, 12.5. So 10, 12.5 is at 7. My halfway point, which is at 6.25, it was at 12.6. So 6.25 0.25 at 12, 7, 8, 9, 10, 11, 12.6, so like here. And then after equivalence at 20 milliliters, my pH was at 1.48, so about there. So it's going to be relatively flat, and then we're going to have our steep change, and then it flattens out again.